Alright, in this video we're going to do CC5 and 6, which is ionic and covalent bonding. Remember, elements want to have a full outer shell, and they will lose electrons or gain electrons or share electrons in order to get that full outer shell. We're going to start looking at metals. Metals, we find them on the left hand side of the periodic table, and metals will always lose electrons to get that full outer shell. When they lose electrons, they become positively charged, so we say they are positive ions. Alright, if it's a group 1 metal, they have 1 electron in their outer shell, and that means they will lose 1 electron. If it's a group 2 metal, they lose 2 electrons. A group 3 metal, it will lose 3 electrons. Okay, because they're forming positive ions, if they lose 1, they're positive 1. If they lose 2, they're positive 2. If they lose 3, they are positive 3. Non-metals then do the opposite. They're trying to gain electrons, and if they're gaining something negative, they end up with a negative charge overall. If it's group 5, it's got 5 electrons in its outer shell. That means it wants to gain 3 more to bring it up to 8 in total. 8 is a full outer shell. If it's in group 6, it's got 6, it needs to gain 2 to have 8. If it's in group 7, it needs to gain 1 electron to have 8. If it's in group 0, it already has a full outer shell. And if it already has a full outer shell, it doesn't need to react at all. If we're looking at the charges, if it's gaining 3 electrons, it's gaining 3 negative charges. So it's minus 3. It's gaining 2, it's minus 2. If it's gaining 1, it's minus 1. If it's not gaining, then it's not going to form an ion, so it's not going to have a charge. Alright, try and fill in this table for me with all of those charges. So question 1, have a go at completing that table. Alright, so I've started it here. Right, look at your group number. These first 3 groups here, these guys are your metals, and your metals always lose electrons. So lose 1, lose 2, lose 3. Group 4 I'm going to skip over. We'll look at that with covalent bonding. Group 5, these guys down, these are your non-metals, and these guys are going to gain electrons. Remember, it needs to add up to 8. So 5 and 3 is 8, 6 and 2 is 8, 7 and 1 is 8. And this one, the last one, they've got a full outer shell. They don't need to gain anything. If we're looking at charges, when they lose, they become positive. They're losing a negative electron. They become positive overall. Losing 1 plus 1, losing 2 plus 2, losing 3 plus 3. If they're gaining something negative. If they're gaining 3, they're gaining 3 negatives. Gaining 2 negatives. Gaining 1 negative. And then at the end, again, you don't need to answer that. They're not going to have ions if they're not losing or gaining electrons. Alright, let's look at this in slightly more detail. Okay, so I've got an example here. I've got lithium, which I'm saying is in group 1. I'm going to write the electron configuration for lithium, okay, which is just how the electrons are arranged. The small number tells me the number of electrons. So 3 electrons in total. I can put 2 electrons in the first shell. I can put 1 electron in the outer shell. If this is an ion, okay, so if it's reacting, because it's in group 1, I know it loses 1 electron from the outer shell. So if I want to write the electron configuration of a lithium ion, it's going to have 2 electrons in the first shell, and it's going to have no electrons now in that second shell. That means the outer shell becomes the first shell, and the outer shell is full. When it becomes an ion, it ends up with the charge. So I'm going to be putting a positive charge on lithium. So this is the electron configuration of a lithium ion. You can see I have lost 1 electron because group 1 metals always lose 1 electron. Now let's look for group 6. So oxygen has the number 8. Tells me it's got 8 electrons in total, 2 electrons in the first shell, 6 in the second shell. And you can see there it's clearly in group 6. Okay, because it's in group 6, it always gains 2 electrons. And if it gains 2 electrons, it goes from 2,6 to 2,8. And you can see when it goes up there to 2,8 that the outer shell is now full. Because it's gaining 2 electrons, it ends with a 2 minus charge. Alright, have a go at doing questions 2 and 3 for me, please. Alright, so I've started it off for the atoms. So sodium has 11 electrons, 2 in the first shell, 8 in the second, 1 in the third. It's in group 1 and it's in period 3. I then asked you for the sodium ion. The sodium ion is a +1 charge, so it's lost 1 electron from its outer shell. That means it's just left as 2, 8 for the ion. Phosphorus, 15 electrons, 2, 8, 5. When it forms an ion, it has a 3- charge, so it has lost 3 electrons. No, sorry, it has gained 3 electrons. So when it gains 3 electrons, those electrons go into the outer shell, and you go from 285 to 288. So we can see it's ending up with that full outer shell. Alright, we've been talking about atoms losing and gaining electrons, but where are those electrons coming from, and where are those electrons going once they're being lost? And what happens is that atoms can only lose and gain electrons when they are reacting with each other. So here I've got sodium reacting with chlorine. Sodium's in group 1. I've just drawn the outer shell. I haven't drawn every electron that sodium has. I'm just focused on the outer shell, and because it's in group 1, it's got 1 electron. Chlorine's in group 7, so it's got 7 electrons in the outer shell. And when group 1 metals react, they always lose 1 electron, and when group 7 elements react, they always gain 1 electron. So what will happen is when sodium and chlorine come together, sodium will lose an electron and chlorine will gain that electron. And what I'm left with then is I'm left with sodium. So I'm just going to draw that empty shell now. I'm left with sodium. Because it's losing 1 electron, it ends up with a +1 charge. Chlorine still has the 7 outer electrons that it always had, but now it's got sodium's electron, which I'm going to draw there as a dot. And it's got a -1 charge because it has gained an electron. These guys now, remember, are called ions. They were atoms over here. Now that they're charged, they're called ions. And I've got 1 positive ion and a negative ion. And opposite charges attract each other. So when they're oppositely charged, they'll be attracted and they'll form a bond. And that's what an ionic bond is. And this is a definition that you need to know. An ionic bond is the electrostatic force of attraction. Electrostatic force of attraction between oppositely charged ions. It's a definition that you need to know. Electrostatic force of attraction between these oppositely charged ions. Other thing you need to know is how to name these ionic compounds. So over here, before they reacted, I had sodium and chlorine. Now that they've combined together, I need to give it a new name. The metal always comes first, okay? So it's still going to start with sodium. The non-metal comes second, but instead of calling it sodium chlorine, the ending of the non-metal changes to "ide", so it becomes sodium chloride. If I reacted sodium with oxygen, it would be sodium oxide. If I reacted sodium with bromine, sodium bromide. So the metal comes first, the name is the same, the non-metal comes second, and it ends in "ide". I want you to have a go at answering questions 4 and 5. Just 4 and 5, please. Alright, so your ionic bond, your definition, 2 marks, electrostatic force between oppositely charged ions. The names, the metal comes first, aluminium, the ending of the second one changes to "ide. So aluminium chloride, magnesium oxide, lithium nitride. That's how we name our ionic compounds. Okay, you also need to be able to write formulas of ionic compounds. So the first one I've got here is lithium nitride. It contains lithium and nitrogen. Lithium's in group 1, so the ion has a +1 charge. Nitrogen's in group 5, so the ion has a -3 charge. And these charges do not cancel out. I've got 1 positive, but I've got 3 negatives. So what I do is I drop and swap. I write the Li and I write the N underneath. The number that's next to the nitrogen crosses over and I write it small next to the lithium. The number that is next to the lithium crosses over and I write it small next to the nitrogen. So I'm dropping the numbers down and I'm swapping them over. I'm not bringing the plus and I'm not bringing the minus. I'm just bringing the numbers. The next one, calcium oxide, contains the calcium ion and the oxygen ion. In this case, 2 plus, 2 minus, the charges do cancel each other out. I don't need to drop and swap, I just get rid of the charges altogether and I put the letters together. The last one, sodium oxide, has a sodium ion and an oxygen ion, +1, -2. The charges don't cancel. I need to drop and swap. I write the Na, I write the O. I cross the numbers. So the 2 that's next to the oxygen comes next to the sodium. The 1 that's next to the sodium comes next to the oxygen. I do not bring the plus. I do not bring the minus. All right, have a go at doing this for yourself. I've told you what the ions are, all right, so I've given you the ions, and you're just going to need to drop and swap it to give me the formulas. Make sure you do not bring the plus and minuses. You're just crossing the numbers. Go through this with you. +2, -1, they do not cancel, so I need to drop and swap. The 1 that's next to the chlorine comes down next to the magnesium. The 2 next to the magnesium comes next to the chlorine. No pluses, no minuses. The +1, -2, they don't cancel, so the 2 that's next to the oxygen comes next to the lithium. The 1 that's next to the lithium comes next to the oxygen. I do not bring the pluses or the minuses. +3, -2, they don't cancel, so the 2 next to the oxygen comes to the aluminium. The 3 next to the aluminium comes to the oxygen. Okay, so just make sure you're writing the letters in the same order that I give you, and then it's just the numbers that you are swapping over. Alright, we've been focused on ionic bonding, but there's another type of bonding called covalent. And in covalent bonding, you've got two non-metals coming together. And the issue here is with the non-metals, both atoms want to gain electrons. Nothing wants to lose electrons. So I've got two chlorine atoms. They both want to gain one electron. The only way they can both end up happy is if they decide to share. And the number of electrons they share is always the same as the number they want to gain. So if it wants to gain one, it will share one. This chlorine wants to gain one, it will share one. Now you have to draw Cl2. So you're told you've got two chlorine atoms. They're going to be sharing electrons, and to show that, I draw the outer shells overlapping. This area here is the shared area. This chlorine will share one electron, so I put one cross inside. The other 6 electrons it has, it will not share, and they stay on the outside. This chlorine here also wants to share one, so I put one dot in the center. The other 6 electrons it's got, it will not share, so they go on the outside. Just double check at the end. I started with 7 crosses and 7 dots. Do I still have that? Yes, I've still got 7 crosses, I've still got 7 dots. Does everything now have a full outer shell? This chlorine now has 2, 4, 6, 8 electrons. This chlorine, 2, 4, 6, 8 electrons. So this is called a covalent bond, and a covalent bond is a shared pair of electrons. That's another definition that you need to know. A shared pair of electrons is a covalent bond. Let's look at another example. Alright, I've got nitrogen and hydrogen. Now nitrogen wants to gain 1 electron, therefore, hydrogen wants to gain 1, therefore it will share 1. Nitrogen has got 5, it wants 8, therefore it needs to gain 3, and it will share 3. Now you're told that when these guys react, you form NH3, so 1 nitrogen and 3 hydrogens. I put nitrogen in the middle because it's got the most electrons to share. It's willing to share 3. So nitrogen goes in the center. I'm going to surround nitrogen by 3 different hydrogens, 1, 2, and 3, because that's what my formula tells me. Now I know that nitrogen's got 5 electrons in total, but it's only going to share 3 of them. I've got 1, 2, 3 sharing spaces, and I've got 3 electrons to share. So it makes sense that it would share 1 electron with this hydrogen on the left, 1 with the hydrogen on the bottom, 1 with the hydrogen on the right. But of the 5 crosses, I've only drawn 3. There are 2 crosses that are not being shared, and they're going to go here on the outside. Hydrogen's only got 1 dot, okay, and it's going to share that 1 electron. So hydrogen shares the electron, so it goes in here. This hydrogen shares, it goes in here. This hydrogen shares, it goes in here. So have I drawn 5 crosses? Yes. Have I drawn 3 dots for my 3 hydrogens? Yes. Does everything have a full outer shell? Well, nitrogen's got 2, 4, 6, 8, so that's full for nitrogen. And each hydrogen, you'll see, has got 2 electrons in its outer shell. For hydrogen, that's a full outer shell because hydrogen's outer shell is the first shell. Okay, remember these pairs are called covalent bonds, and the definition is a shared pair of electrons. Right, have a go at doing questions 7 and 8. Alright, your definition is your shared pair of electrons, your dot and cross diagram. Hydrogen's got one electron. It's got one, it wants to gain one more, so hydrogen will share the only electron it's got. Hydrogen always shares its electron, so hydrogen will share an electron with oxygen. This hydrogen will do the same. You should never have any electrons drawn in the outside for hydrogen. It's only got one, it always shares it, so never have any on the outside. Oxygen's got 6 electrons in its outer shell. It wants to have 8. So if it wants to gain 2, that means it's also going to share 2. Okay, so if it's going to share 2 and there's 2 sharing spaces, we'll share 1 with this hydrogen, it will share 1 with this hydrogen. Okay, but it's got 6 in total and I've only drawn 2. That means there's 4 left over that aren't being shared at all. Now I've drawn my 6 crosses for oxygen, 6 electrons. I've drawn 1 dot for each hydrogen. Oxygen has a full outer shell, 8 electrons. Each hydrogen has got 2, which is a full outer shell for hydrogen, and all of my electrons are in pairs.